processes are all changed to some extent. Changes. Say, for example, one very known phenomenon to us is the El Nino. This El Nino occurs due to the uh, change in sea surface temperature over the Pacific Oceans in both margins of the Pacific Oceans. Now, this temperature change which cause El Nino, because of this, not only the sea surface temperature was changed, but along with it, the precipitation, that is the rainfall, the wind movement pattern, the depth of thermocline, and the ocean currents, that all will change simultaneously with simple change in sea surface temperature. Now, this pattern of change during El Nino may occur in 7 year interval, and that indicates or that gives us example that what happens during such natural climatic change. The thing is that, as I already told, climate is a dynamic. So every now and then things, almost every year, in every decade, in every century, the climate is natural. But the question is, why we are so concerned about this? It's a natural thing. So anybody does not have any control on this natural process. They cannot control the element, they cannot control the climate. It's a natural thing. Then why we bother? The thing is that along with the natural Now, if we try to reasons, there are some mechanisms by which the energy imbalance in the earth occurs and which ultimately results to climatic changes. Now, if we try to see the mechanisms by which the climatic change occurs, then we can divide or we can group these mechanisms into two broad groups. One group, that is the terrestrial mechanisms by which climatic change can occur, and the another group is the extraterrestrial mechanisms or extraterrestrial causes by which climatic change can occur. So these are also called internal causes and external. So among the external causes, it includes the solar activity, It includes Earth's orbital change through time. It also the meteorites impact. Among internal causes, again we can group them into two subgroups, that is internal causes which are natural. Those are volcanic eruption, change in land ocean distribution, and that occurs due to uh, tectonic activity, that is plate tectonics. And the other part for which we are very much bothered, that is the internal causes which is anthropogenic, that is which is man-made. It includes emission of more and more greenhouse gases, emission of more and more dust particles which causes more cloud covering, and lastly the land use pattern by the humans that actually alters the topography of any area, and when this alteration occurs, the topographic change occurs, that also brings a lot of physical, chemical and biological changes. Now, as I know that the previously mechanisms, that is the terrestrial and extraterrestrial mechanisms, that basically force the climate to change. So scientists called these mechanisms as climate forcing, because they are the causes, they are the reasons which force the climate to change. Now, if we look at general order of these climate forcing mechanisms, then there are lots of mechanisms which can upset the global energy balance and thereby cause climate changes. So what are those? The orbital change of Earth, solar activity of Sun, meteorite activity or meteorite impact on Earth's surface, plate movement, that is the plate tectonics, proportion of aerosols in the atmosphere, and lastly the greenhouse gases amount in the atmosphere. So coming to the first mechanism, that is one next from nearly more elliptical, and this variation is known as eccentricity of Earth's orbit. Now as we can see that when the Earth's orbit is more circular, then almost in every place of its orbit, Earth receives almost same amount of incoming solar radiation. But when it is more elliptical, then there are two positions in which the amount of solar radiation difference is maximum. So this point receives maximum solar radiation as it is more close to sun, whereas this point receives minimum solar radiation as it is far away from the sun. And this eccentricity cycle occurs in 1 lakh years. Depending on this, the amount of incoming solar radiation received on Earth's surface changes from time to time. That's time span. And as you came to know from your previous class, that depending on this obliquity, the seasonal differences in solar radiation received at different latitudes occurs. So close to uh, perpendicular position, then the seasonal variation will be less, and when it is more oblique, then there will be more seasonal variation at different latitudes of the earth. This is known as the obliquity cycle. And the last cycle, that is known as precession of, and the positional change of Earth's orbital cycle with time make precision of equinoxes. So depending on these, the energy received on Earth's surface also affected, and generally this cycle occurs in 23,000 year time span. So these three orbital cycles, these three changes in orbital position of Earth with respect to time causes the change in distribution of solar energy, and that will affect on Earth's climate. The next cause or the next mechanism due to which Earth's climate change occurs is known as the solar variability. Now, solar variability, now if we look at the change in solar energy output, that can be identified from the luminosity or brightness of the sun, as well as often we found some spots, some dark spots over the sun's outer surface. Now these dark spots are known as sunspots. Now the number of sunspots indicate us that how much energy is radiating approximately from the sun. When there is lot of sunspot, that means higher number of sunspot means the sun radiating higher amount of energy, and due to this radiation, due to this energy release, locally those areas become relatively cooler with respect to its surroundings. So that results the place or the portion of the sun appears dark, and that is called as sunspot. So higher sunspot means higher amount of energy radiating out from the sun. Similarly, low number of sunspots indicates that lower amount of energy radiating out from the sun. Now, if there are more sunspots found in the Earth's surface, then a lot of energy will also received on the Earth's surface. So often we heard the term solar storm. Basically, that is an abnormal event during which a lot of energy is radiating suddenly from the sun, and that will move towards Earth and all other planets as a storm. So as storm is an occasional event, these kinds of uh, energy released, sudden high amount of energy released is also occasional. So that is why it is known as solar storm. But every day there is energy release occurs from the sun, and that can be uh, crudely identified, crudely estimated by the number of sunspots. Now, if we look at the sunspot numbers with time, you can see in this first curve that sunspot numbers are plotted against the years. Then you can see there is a cyclic change of sunspot numbers. Sunspot sometimes becomes high, about 200 to 250 in certain period of time. You can see almost it variance in um, every alternate 10 years. So in the year 1980 it is higher in number. Again in 1990 it is showing higher numbers. Around 2000 it is also showing higher numbers, and around 2010 it is decreasing. So this higher number of sunspots in 1980, 1990 indicates that during these years there is more amount of energy released from sun. So definitely Earth will receive more amount of incoming solar radiation. So you can see that this cycle is occurring approximately in every 11 years. Now, if you look at the relationship between temperature and this solar activity, you can see the red color line is basically indicating the change in temperature through time. You can see in the x-axis the year or time is plotted, and this yellow color line is indicating the solar irradiance, that is the solar activity. Now, interestingly, you can see up to 1960 or 1965, this red color line, that is the solar activity line, and this that is the temperature line, and this yellow color line, that is the solar activity line, is almost parallel to each other. That means with change in solar activity, the temperature on Earth is also changing. But after 1960s or 1970, the solar activity is more or less constant with uh, fewer peaks and drops. But exceptionally, the temperature of Earth is increasing in this last 50 to 60 years time. Now this is alarming to us. So this time this temperature change on Earth is not due to the solar activity. So it in it involves some other mechanisms by which this change in temperature, or more precisely this increase in Earth's temperature, occurs. The next mechanism by which Earth's climate can be changed or can be disturbed is the meteorite impact. Meteorite impact occurs around 65 million years ago, and that caused a major mass extinction on Earth. That is the last major mass extinction, that is the KT mass extinction. And due to this meteorite impact, which is thought one of the uh, probable reason for which the mass extinction occurs, and that affects almost all the regions of the earth, and all kinds of animals, all kinds of plants, including the infamous dinosaurs. They are hardly affected during this mass extinction phenomena, which is basically caused by the meteorite impact. Now, what happened due to this meteorite impact? The meteorite impact, or after the impact of the meteoritic bodies on the Earth's surface, the immediate impact found is the melting of the rocks where the impact occurs. And we all know that the natural rocks occur on the Earth's surface. They are the natural reservoirs of many of the toxic gases or many of the toxic elements. So when this melting of uh, superficial rocks occurs due to meteorite impact, there will be release of carbon dioxide and many other toxic gases. So these toxic gases, after releasing from the Earth's superficial rocks, they added to the atmosphere. So the chemical composition of the Earth atmosphere will be changed. Next, temporarily heating the surface of the Earth, as due to this impact, several dust particles are added on the atmosphere, and these particles are in high energy state. So lot of interaction between them occurs, lot of collision between them occurs. So that results in immediate increase or temporary heating of Earth's atmospheric temperature. Now, after some time, when these mutual collisions of the dust particles is settled, then the fine particles and all the vaporized materials, that includes the water vapor, that includes the fine dust, all other toxic gases, they still remain in the atmosphere, and these elements basically causes blocking out the sun radiation. So the solar radiation is basically trapped by these elements in the atmosphere. So they are not, solar radiation is not able to reach the Earth's surface, and as there is no solar radiation reached in the Earth's surface, so the photosynthesis process is hardly affected. So all the photosynthetic organisms, particularly the plants, they are hard hit because of this blocking of sunlight by these dust and other toxic gases, and that basically reducing the biomass and the productivity. Lastly, the toxic particles which are suspended in the atmosphere with precipitation, they are included in the raindrops, and they came with precipitation on the earth's surface as acid rains, and that can cause severe damage to the properties or to the uh, living beings. And other toxic elements like the iridium, all these things, that also comes on the earth's surface with the rainfalls, so that will have hardly hit, or that will affect severely uh, the living beings of the earth's surface. Meteorite impact can often produce firestorms for thousands of miles. So thousands of miles can be affected by this sudden increase of temperature, and due to this increase of temperature, often fire is found to occur near the impact site, and that can affect a large area. So in this way, meteorite impact can change the climatic conditions of Earth in short time span as well as in long time span. Now here you can see a picture. This is the picture of the year 2020, that is the previous year, in which one meteorite impact is come very close, although it is few lakhs uh, kilometer away from Earth, but that will also very close to the Earth in terms of astronomical scale. So many scientists are very much bothered about this phenomena when this meteorite suddenly came very close to Earth, because any disruption of the path of this meteorite uh, may cause change of direction, and thereby the meteorite can hit the earth. And when or if this change in direction of meteorite occurs by some way and it hit the earth, then as we discussed already, there will be lots of devastation may occur. The next cause or next mechanism by which uh, climate change can occur is known as the tectonic activity. Now we all know that Earth's surface is made up of numerous plates. The plate is the mainly the upper part of the crust with very uh, smaller amount of the upper part of the upper mantle. So that is the solid part of the surface of the earth. Now there are 12, 12 major tectonic plates found over the place. Tectonic plates are found with time, and thereby the physical, chemical, and biological processes are also changed with time. Here you can see that the positions of tectonic plates takes place uh, different shape with different tectonic movements at different time interval. So you can see at Permian there is almost a major landmass. So it is known as a supercontinent, that is the Pangea. And in Triassic, the breakup of supercontinent Pangea occurs mainly the southern part. In Jurassic, you can see the southern Gondwana land, continental landmass. They are almost all are broken, and they are moving towards northern hemisphere. This is the position during Cretaceous, and this is the present day position. So you can see the continental landmass positions are also changed with time, and depending on that, the uh, continents or the landmasses, they occur at different latitude conditions over time. And as we all know that depending on latitude, the incoming solar radiation received at the earth's surface varies. So a single area, as say for example the Indian landmass, during Permian time it is almost close to South Pole, almost it is near 60-degree southern hemisphere. And through time you can see that Indian landmass gradually moving towards north, and during Cretaceous it is in the subtropical portion of the southern hemisphere, whereas if you consider the present position of India, it is in the subtropical portion of northern hemisphere. So during different times, the continental landmasses will receive different solar radiation, and not only that, all the superficial processes are also changed because more and more uh, continental breakup, that will cause more and more oceanic areas to open up. So the superficial processes in the land will also change. The atmospheric movement or wind movement pattern will change depending on the uh, distribution of continents. Not only that, the oceanic current pattern will also change due to this distribution of land and oceans. So with time, as tectonic activity occurs and the land masses changes their position, size and shape, simultaneously the superficial processes, particularly the wind movement and ocean currents, that will change from time to time. Not only that, but along with this, plate tectonic enhances the volcanic activity. So volcanic activity is often found associated with the plate tectonic processes. Now, as we know, during the volcanic eruptions, along with the molten material, along with the lava, also some ash or numerous toxic gases, which are known also as aerosols, they are also coming out along with the molten material. And these aerosols, these ash particles, fine particles, they are directly thrown into the atmosphere. So these aerosols may leave or may remain suspended in the air for a long time. Now these aerosols may be solid particles or maybe liquid particles. Aerosols may be naturally occurring like the particles from trees, the sea salt, dust or volcanic dust. Also, the aerosols may be anthropogenic, that is, they are added into the atmosphere due to the human activity, like the increased burning of fossil fuels, more and more atmospheric gases, more and more toxic gases are added into the atmosphere, more and more smoke, agricultural dust, that is the land use pattern change. So often we are blowing dust to the atmosphere. Now these aerosols affect the Earth's climate differently depending on the mainly on the particle size. So sometimes these aerosols may interrupt the incoming solar radiation. So thereby the incoming solar radiation becomes trapped by these aerosols, and basically the incoming solar radiation is scattered by these dust particles. Uh, it also result in the formation of more cloud condensation, and thereby it results in increasing albedo. So as lesser amount of incoming solar radiation is able to reach the Earth's surface, so indirectly there will be a cooling due to the presence of higher number of aerosols. But alternately, the outgoing terrestrial radiation, that is the long wave radiation which is emitted back into the space, which is emitted back into the atmosphere from the earth, that will also trapped by the suspended dust particles, and particularly they are trapped by the large size dust particles. So again, that terrestrial radiant energy comes back to the earth surface, so that will increase the surfacial temperature of earth, and ultimately it results in warming of the uh, earth surface temperature. So if the atmosphere is covered with fine dust particles, then there will be a indirect cooling due to uh, scattering of incoming solar radiation. But if there will be a large number of or higher size dust particles as aerosols in the atmosphere, then there will be a global, there will be a warming effect observed in Earth atmosphere conditions. So depending on the particles, the temperature of the Earth change, and simultaneously other processes like precipitation, the wind movement pattern, that will also affected by the amount of dust particles. Now, this is the most significant agent or most significant mechanism thought in the present day, due to which scientists or all the natural workers, they are very much conscious about the present day climatic changes. Now, Earth atmosphere absorbs the incoming solar radiation from the sun, and as well as the energy emitted from the Earth's surface, that will also trap in these atmospheric gases. Now, the gases which cause this trapping of outgoing terrestrial radiation are the greenhouse gases. The major greenhouse gases are the carbon dioxide, methane, carbon monoxide, nitrous oxide, hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride. These are the examples of greenhouse gases. Now, these greenhouse gases particularly trap the long wave radiation. So, mainly the outgoing terrestrial radiation, due to which the Earth's surface becomes cool at night, that is basically trapped by these greenhouse gases. Now, these processes of trapping of greenhouse gas by these this process of trapping of outgoing terrestrial radiation by these greenhouse gases basically maintain a balance of temperature on the Earth's surface. If there are no greenhouse gases, so there will be huge fluctuation of temperature between day and night, and because of the presence of these greenhouse gases, there is a steady temperature condition. Although there are fluctuations, there are variations of temperature during day and night, but it is in a limited variation, limited fluctuation condition of temperature found on the Earth's surface. Now, one question comes here, that why these gases are called greenhouse gases. If you look at the uh, plantation of certain uh, plants which are mainly found to occur in the cold areas, particularly in the high altitude areas or very near to subpolar regions, if a equatorial or subtropical region person, that is a temperate region person, try to plant those trees or plants into his own house, then he or she must maintain the temperature, and for that the person has to set up a particular structure with the help of the green glasses, and due to this presence of green glasses, the inside temperature of the structure remains warm in contrast to the surroundings. So particularly this is effective for people living in the cold region, and if they are trying to plant a tree of temperate regions. So they then use these green roof glasses, and inside these green roof glasses the temperature remains relatively high compared to the surroundings. Basically that green glass traps the inside uh, temperature, which is not able to go out. Now, in nature, the gases like carbon dioxide, carbon monoxide, methane, nitrous oxide, they also function like the uh, green colored glass. So they traps the outgoing terrestrial radiation, due to which Earth's surface will be never so cool that it becomes inhabitable for humans and other organisms. So there maintains a balance between the temperature fluctuation between day and night. So in a way, these greenhouse gases is favorable for us to sustain in Earth. The greenhouse gas content of the atmosphere is being altered by human activity. So if the greenhouse gases is favorable to us, that is, it uh, holds or it uh, controls the fluctuation of temperature on our surface between day and night and between seasons, then why we are bothered about the increased amount of greenhouse gases in the atmosphere? Because the greenhouse gases is favorable to us only when there is a uh, poor proportion of the greenhouse gases is more or less uh, what it is now or what it is few years ago. But with time going, with more advanced technologies people discovered, we are regularly increasing the amount of greenhouse gases in the atmosphere. Now say for example, if there are 100 number of gas molecules in the atmosphere, so definitely more amount of greenhouse gas including into the atmosphere is costing reducing of other gases into their abundance. So we are basically increasing the proportion of greenhouse gases into the atmosphere in costing of uh, re- reducing of other valuable gases, say for example oxygen. So we decrease the percentage of oxygen but increasing the amount of greenhouse gases. So again a chemical composition of the atmosphere is changed. Now along with the greenhouse gases which is artificially uh, involved in the atmosphere by the humans, that will affect the Earth's climate, and these greenhouse gases left in the atmosphere for almost a century. Also, along with the greenhouse gases, we are also including lots of particles, dust particles into the atmosphere. So they also affect the climates, but the effect of particles or the particles, dust particles found in the atmosphere for only 1 week after they will settle. So although more and more dust particles and greenhouse gases added into the atmosphere, the effect is more observed, particularly for greenhouse gases. So that is why we are more concerned on the increasing amount of greenhouse gases in the atmosphere. Now, what change occurs due to the increased amount of greenhouse gas into the atmosphere? If we look at the average global temperature, this blue colored line, and the atmospheric carbon dioxide concentration, we can see that these atmospheric carbon dioxide is almost mimic the global temperature. So basically the global temperature trend follows more or less very closely the atmospheric carbon dioxide concentration level. So whenever there is higher amount of atmospheric carbon dioxide, average global temperature is higher. Whenever there is lower amount of atmospheric carbon dioxide found on Earth, the average global temperature decrease. But the thing is, previously all these variations occurred naturally. So no organism or anything does not have any control over this variation. But this time, nature is not responsible for this change in atmospheric carbon dioxide or other greenhouse gases. But we, a living organism on Earth, we destroying the balance of the atmospheric gaseous composition by incorporating or by adding more and more greenhouse gases in our day-to-day life activity. Now, what happened by which or what are the causes by which these greenhouse gases uh, added into the atmosphere and what are their effects? Firstly, it is the increased amount of industrialization. The global carbon dioxide ratio proportion is found to change exceptionally in the last 150 years. That is also known as the age of industrialization. So after lots of industries came into the day-to-day life, more and more toxic greenhouse gases are added into the atmosphere as the waste product of those industries. So industrialization, more and more industrialization increases the amount of greenhouse gases into the atmosphere. Not only industrialization, due to the human activity, and due to the increased amount of population, often we go for deforestation without thinking any other possible future effect. So trees are randomly cut to expand the habitable area of the human activity. Sometimes we simply cut a tree because of some kind of enjoyment. And we all know that these trees are the natural reservoirs of carbon dioxide because plants take the atmospheric carbon dioxide during the photosynthesis process. So if we cut the trees, then the natural reservoir for carbon dioxide is basically destroyed. And simultaneously, we are also choking the mechanism by which oxygen is added into the atmosphere. So in both ways, we are affecting the mechanism in which carbon dioxide can be consumed from the atmosphere. Also, we are choking the process by which oxygen, which is a required gas for almost all living beings to sustain in earth, to continue their respiratory process, that will also affected by the human practice. Human activities like uses of air conditioners, refrigerators, that will add a lot of chlorofluorocarbons, hydrofluorocarbons into the atmosphere. And these CFC and HCFCs, they destroy the Earth's protective ozone layer. And we all know that this ozone layer is basically protecting us from the harmful ultraviolet ray of sun. So if the depletion of ozone occurs, then those harmful ultraviolet ray will reach the Earth's surface and that will cause severe damage to mankind and other organisms also. So not only we are increasing the amount of carbon dioxide, we are decreasing the amount of oxygen from the atmosphere, as well as we are decreasing the amount of ozone, which is a natural barrier, which is a natural protection cover for the harmful ultraviolet ray, that will be also disturbed, that will be also damaged by the human activities. Now, the alarming thing, that is plants with very little greenhouse effect, that means very low amount of greenhouse gases into their atmosphere, they are either very cold like Pluto, in which the temperature is about minus 370 degree Fahrenheit. So in Pluto there is very little amount of greenhouse gases. So the planet is very cold. Or if there is very low amount of greenhouse gases into the planet's atmosphere, then there will be huge temperature fluctuation between day and night observed. Example is Mars. You can see that about 300 degree Fahrenheit temperature difference observed between day and night temperature in Mars. So lower amount of greenhouse gases is not favorable for biological entity to sustain. So either the planet will be extremely cold or there will be extreme temperature fluctuation between day and night. Now in planets which have abundant greenhouse gases, exceptionally high amount of greenhouse gases, that will cause increase in temperature of the planet. The planet becomes very hot, like the Venus, in which the temperature is about 855 degree Fahrenheit. So neither very low amount of greenhouse gases into the atmosphere nor a very high amount of greenhouse gas in the atmosphere is favorable for living beings to sustain. It is the concentration found in Earth that is suitable to maintain the temperature balance, and thereby life in Earth can sustain in this situation. So any disruption, any change from the concentration of uh, atmospheric carbon dioxide content may either lead it to become extremely cold, that is when if carbon dioxide concentration or greenhouse gas concentration becomes exceptionally low, or like the current trend, that is the increasing amount of greenhouse gases may lead our temperature to increase day by day, like the case of Venus. So ultimately the Earth will be a hot, uninhabitable planet. Now, what are the components of climate that are affected by these climatic changes? The first component is the atmosphere. It is the fastest changing and most responsive component, previously considered the only changing component of Earth, but presently, along with atmosphere, other things like the oceans, that is the hydrosphere, is also found to be affected. It is the fluid component covering of the Earth's surface, and it plays a central role through its motion and heat capacity for the distribution of temperature of one point to another point, and that is why the equatorial region neither becomes too hot and the polar region neither becomes too cold. The ocean interacts with the atmosphere and thereby distribute the atmospheric temperature from place to place. It will also cause formation of clouds, and uh, that will ultimately come down on the Earth's surface in terms of precipitation. Cryosphere, that is the snow covered area of the Earth's surface, that will also be affected. Mainly the snow covered areas are found in the high mountain peaks or in the polar regions. The snow are thought to be the largest reservoirs of fresh water, and as the snow are very light color, almost white, so they have a high reflectivity and low thermal conductivity. Now if there are increased amount of temperature occurs over the earth's surface, then gradually with increasing temperature the snow melts, and thereby the reflectivity, the thermal conductivity, so all the things will change simultaneously. Land and its biomass, they are slowly changing with time. Faster changing found in lakes, streams, soil moisture, vegetation cover, and lastly the human interaction. So agriculture, urbanization, industrialization, that will also affect it with climatic changes, because the climatic changes uh, affect all the living beings over the earth's surface. So if human itself is affected, then simultaneously the things like agriculture, urbanization, that will be also affected by climatic changes. Now, the evidences which points us that there is climatic change occurring. What are the evidences? Average global temperature increase year after year. Earth's climatic zones, particularly the temperate and uh, subtropical regions, they are increasing their area gradually. The polar regions, polar zones becomes narrower, so poleward extension of tropics and temperate zones increase indicate that the Earth's average superficial temperature is increasing day by day. Due to increase in temperature, the volume of water will also increase, so that will result sea level to rise, and average sea temperature will also increase. So that will affect the sea level, the coastal areas will be affected. Not only that, the marine organisms will also affected due to the increase in ocean temperature. Ocean becomes acidic due to the change in chemical weathering pattern. Wind and ocean circulation pattern will also changes. Increase in intensity and frequency of tropical cyclones, like what we evidenced just few days ago in the east coast of India as well as in the west coast of India. The intensity, the frequency, all are changing. Net melting of glaciers result in pullback of the snow line. The famous example is Gangotri Glacier, in which in almost in every years it is found that the snow line of Gangotri Glacier is receding. That is, it goes more higher part of the Himalayan mountain ranges. Seasonal timing and duration will also changes. Uh, Shifting range of plants and animals will also occur. So every plant and uh, animal, it has a favorable temperature condition. So if it not manage to cope up with this changing condition, then they will move their residing place from one temperature region to another temperature region. Now, apart from this, the climatic change is also indicated by some extreme events such as the wildfire. In previous year, we heard many times about these things. That is the wildfire found in Amazon, wildfire found in Australia, as well as in India, and particularly in various uh, places of West Bengal. There we also evidence wildfire, but it is not as vast like the Amazon or what it happened in Australia. But still, a lot of fire affect the local plant population and the local ecosystem. And there will be severe drought, extreme dryness, and increased and frequency of tropical cyclone will also uh, enhanced. The frequency will be enhanced, the intensity will be more vast. Now, the effects on ecosystems. So, there are certain kinds of organisms which are particularly able to survive in a definite pressure, temperature, salinity conditions. Say, for example, the corals, particularly the uh, colonial corals, the hermatific corals, they are occurring in a unique ecosystem and they cannot handle higher temperature. The hermatific corals, they are more or less found to occur in 20 degree centigrade temperature. So with increased amount of sea temperature, seawater temperature, the corals are hardly affected. There will be more and more number of wildfires, and that will affect heavily the forest ecosystem. So not only the plants are destroyed, but all the living beings from tiny microscopic organisms to macroscopic organisms, from herbivores to uh, tertiary level carnivores, they are all affected with wildfires, with this firing event in the forest. Up to 30% of species will be at increased risk for extinction due to the rapid changes in the ecosystem. So you can estimate the vastness, the tremor of this ecosystem changes. Another thing is the ozone hole. Now, the first thing came into our mind by the term ozone hole, that there is a gap, there is a hole formed in the ozone layer. Now we all know that ozone layer occurs in the upper part of the stratosphere. But this term ozone hole basically misleads us. There will be no such hole. Basically what happened, that there will be depletion in ozone concentration. Now we all know that ozone layer is basically protecting us from the ultraviolet radiation, particularly the UVB, which have the wavelength between 280 to 315 nanometer. That wavelength ultraviolet ray is basically trapped by the ozone layer. The other portions of the ultraviolet ray, which have wavelength between 315 to 400 nanometer, that come to Earth surface. Now, the UVB, which is trapped by the ozone layer, is dangerous for us, particularly the humans, and also it will affect other organisms also. If humans are exposed under UVB, that will increase the risk of skin cancer, cataracts, and suppressed immune system. UVB exposure can also damage terrestrial plant life, single cell organisms, and aquatic ecosystems. So, ozone layer basically acts as a barrier and traps the UVB, and for that, the Earth's surface becomes favorable to have to sustain for many of the living beings. Now, the global decrease in stratospheric ozone is well correlated with rising levels of chlorine and bromine in the stratosphere, and that chlorine and bromine is added in the stratosphere by the human practice, by humans, by increased amount of CFCs, by increased amount of HCFCs used in our day-to-day life in almost every advanced instruments like the refrigerator, like the air conditioner, like the spray bottles, spray cans. Uh, from these, these CFCs and HCFCs are blowing out and they are added into the atmosphere. So these gases basically affect the ozone layer and decreasing their amount in the stratosphere. Now, as I told that ozone hole is basically a term which mislead us. Basically, there is no hole, but instead of that, the depletion of ozone layer is found exceptionally in the stratosphere. And particularly, this depletion of ozone layer is found in a higher amount in the polar skies, in the polar atmosphere, and among the poles, particularly in the Antarctic or particularly in the South Poles, that depletion occurs mostly in the months of August to October. Now, what happened during these months? In springtime, that is in the month of August to October, in the stratosphere over Antarctica, the ozone is rapidly destroyed by chemical processes. As winter arrives in the southern pole, a vortex of winds develops around the pole, and that basically isolates the polar stratosphere. Now, when temperature drops below minus 78 degrees centigrade, thin clouds form of ice, nitric acid, sulfuric acid mixtures are formed, and the chemical reactions on the surface of the ice crystals occurs in the presence of these nitric acid and sulfuric acids, which produce CFCs naturally, and these CFCs occurs destruction of ozone gas, and due to this depletion of ozone found in the Antarctic atmosphere, and that is why it is called as ozone hole. So over the course of 2 to 3 months, approximately 50% of the total column of ozone in the atmosphere disappears in the Antarctic atmosphere. So you can estimate the vastness of the destruction of ozone. So as more and more ozone destroyed by these uh, CFCs chemical reaction with the ozone layer, so there will be more and more UVB is now able to go through from this ozone layer, and that UVB ultimately reach the earth surface. Now these phenomena, this ozone depletion, if it continues in all the latitudinal conditions of the earth, then that will be hardly alarming, that will affect hardly to humans and all other organisms of the earth. Just because that phenomenon is found to occur over the Antarctic poles where there is almost no humans. So that is why we are often neglecting this thing. Now the thing is, here CFC is forming due to some chemical reaction naturally in this cold temperature, in presence of ice crystals, in presence of nitric acid and sulfuric acid. But the thing is, we, the humans, after knowing these things, we are also adding these things artificially to the low latitude areas. So what occurs in the high latitude polar areas naturally, in low latitude areas, we are producing these gases and mixing them or spread them into the atmosphere. So the depletion of ozone layer is also occurring in the low latitude areas. Now what happens in this ozone destruction? Basically the CFC, that is the chlorofluorocarbon, one carbon is surrounded by two fluorine and two chlorine. Now when ultraviolet ray falls over this CFC, one chlorine is breaking down, it is separated from the CFC, uh, and this chlorine is basically reacting with the ozone layer, and one oxygen atom is ripped from the O3 molecule. So O3 when reacts with this anion, that is this chlorine, chlorine take one oxygen molecule, so O3 now destroyed. The property of ozone is lost. So O3 destroyed to O2 and a compound of chlorine and oxygen. So in this way, CFC destroys the ozone layer in presence of ultraviolet. So more and more CFC, more and more ozone destruction will occur. And what happens in polar region, particularly in the Antarctic region naturally, that will artificially producing in the low latitude areas. So what can be done? Firstly, we must admit as a educated part of the society, we have to take the responsibility to make people aware about this fact, about these cause and effects of climatic changes, because no agency, no government or no scientist can fix the climate once it is changed. So if by some way earth becomes inhabitable like Venus or like Pluto or any other planet, then anyone in the world cannot fix it. So we got here, we have to face this critical situation because of these, uh, because of our lifestyle, because of our habit. So definitely, not only we have to make aware about the facts and effects of climatic changes to common peoples, to laymen, but firstly, we the educated people has to change our lifestyle, has to change our daily practice. Otherwise, we all have to face it in near future. Maybe we as a individual will not face the extreme severity of these climatic changes, but our future generations will have to face it. So what we can do, we can use more effectively the energy sources. We have to reduce the consumption of electricity and other energy sources which is non-renewable. Instead of this non-renewable energy source use, we may go for uses of more renewable energy like the solar energy, like the windmills, from which we are basically using the natural things, and from that we are producing the energies, we are producing electricities instead of using the uh, fuels, using the natural fuels by combustion of natural fuels producing energy. So instead of using more and more non-renewable energy, we have to move towards the renewable energy. That will reduce the climatic change in a huge amount. And lastly, the capturing of carbon dioxide and other greenhouse gases should be done. Now, capturing of carbon dioxide, or it is of known as carbon dioxide sequestration, that can occur in two ways. It can occur in artificially by some scientific methods in the hard rocks, or the most easy way by which carbon dioxide can be captured is by plantation. So not only after plantation these plants will capture the carbon dioxide naturally, but also it will produce oxygen. So there are many small steps we have to take, and that steps will ultimately add up to prevent the climatic changes and keep the planet Earth in its habitable condition. So yes, climatic change matters, and as you may very aware in this present pandemic situation, present corona pandemic situation, that stay home, stay safe is the best practice. So there's no place like home. It is the most safest place in which we live. Now, if we think large, Earth is the only planet into the entire solar system in which till date living beings are reported. So we have to prevent it from further climatic changes, due to which the living beings may be highly affected in near future. So we have to keep our home planet, keep our planet in a safe way so that our future generation can live happily here. So the slogan of the present day is go green, that is plant more trees and use more and more renewable energy. Thank you.